Hello everyone, my name is Pragati Srivastava. In this lecture, I am going to discuss about block diagram reduction technique and its rules. So let's start with the need of block diagram reduction technique. So it is very important to understand why there is a need to learn this method, block diagram reduction technique. Suppose if we consider the block diagram of any complex system, it consists of multiple blocks. So by using this block diagram reduction technique, we can reduce these blocks into single block. Or sometimes it may sometimes require to rearrange the blocks from its original order. So this is the one purpose, that is to convert the multiple blocks into a single block. And then we can use this block diagram reduction technique to calculate the transfer function of the given complex system block diagram. So this is the requirement. Now let's understand what is block diagram. A block diagram is basically modeling of any simple or complex system. It consists of multiple blocks. So just see on the left hand side, I have shown the complex system block diagram. So this is the block diagram which consists of multiple blocks which are connected together to represent a system to explain how it is functioning. So now by using the block diagram reduction technique, we can reduce these multiple blocks into a simple single block. So just see on the right hand side, simple system is there in which only one block is there, G1S. So by using block diagram reduction technique, we can reduce this whole complex system into a single block. And this block diagram also represents the mathematical relations between the elements of the system. So from this, we can understand why we are studying this block diagram reduction technique. Basically, to reduce these blocks into a single block, we have to learn for this some rules. So this block diagram reduction technique depends on some rules. So before reduction, we have to understand those rules. So now in the next slide, I'm going to explain you the rules of block diagram reduction. Now consider first rule. So first rule is blocks in series or cascade. So in block diagram, if you find the two blocks, two or we can say many blocks connected in series or in cascade, means in such fashion. They are connected. Suppose these two blocks are connected like this. We can say that these two blocks are connected in cascade or series, right? So in this picture, I have shown only two blocks. It may be, or there may be 2 or 3, 4, 5 blocks which are connected in cascade. So I want to convert these two blocks into a single block, right? So how I will approach, how I will do this? I will just multiply the gain of these blocks. So whenever the blocks are connected in cascade, we have to multiply the gains of individual blocks. So here two blocks are there. So we will multiply G1 into G2. So the transfer function means, see, wait. See, I want to convert this whole block into a single block. So what will be the transfer function? Transfer function will become G1, G2, here input U1 and output is Y2. So this two blocks I have reduced into a single block which is having a gain G1, G2. Input is U1, output is Y2. So if I want to write down the transfer function of this block, we will write Y2s upon U1s is equal to G1, G2. So like this, if two blocks are connected in cascade, we have to multiply the gain of these two blocks. Now the second rule is blocks is connected in parallel. So suppose if you find such type of pattern in the block diagram, like two boxes are connected in parallel. So first we have to understand whether they are connected in parallel or not. So just see, when we will consider these two branches are connected in parallel, we have to see the direction. It is very, very important to see the direction. Just see, this point is the input point from where this G1 block is going towards the summation point. So its direction is unilateral, unidirectional, right? Now, again, from this point, the G2 block is moving towards this summation point, right? So this signal is moving towards the summation point, and from this signal is also moving towards the summation point. This branch is having the gain G1, this branch is having gain G2. Now we have to see the polarity. G1 is having positive polarity, G2 is having also positive polarity. So these two blocks, if they are connected in such a fashion, so we can say that these two blocks are connected in parallel. So the gain of these two blocks will be the algebraic sum of them. So what will be the algebraic sum? For that, you have to see this sign. So G1 is having positive sign, G2 is also having positive sign. So the total gain of these two blocks will be G1 plus G2. This single block we will get. So basically by using this rule, I have converted this whole block into a single block, which is having input US and output YS. And if I want to write the transfer function of this block, so I will write YS upon US is equal to G1 plus G2. Suppose the blocks are connected like this. Summation point is there. One block, second block, third block, fourth block. Suppose 4 blocks are there and they are coming from the same input. Like this. This is U. Direction is very, very important. We have to mark the direction. And they are moving towards this summation point. Like this. Like direction is unidirectional, right? This is G1. This block is having gain G2. This block is having gain G3. And this is having G4 gain, right? Output is Y. Now, this block is having the polarity of plus, ye ho gaya minus, then again plus, and suppose it is having the polarity minus. So the overall gain, these 4 blocks are connected in parallel, we can say, right? So the overall gain of these blocks will become G1 minus G2 plus G3 minus G4. They will come into one single block. Here we will write input U and here output Y. So the overall transfer function will become Y upon U, which is equal to G1 minus G2 plus G3 minus G4. So if blocks are connected in series parallel, so we have to take the algebraic sum of those blocks, right? So this is the rule number 2. Now we are moving towards rule number 3. Now the third rule is moving takeoff point after a block, right? So for this, first understand which point is called as takeoff point. Just look at this figure on the left hand side. Here input U1 is coming, input signal U1 is coming towards G1 block, right? And the same signal I'm fetching from this point. From this point, I'm fetching the same signal, right? U1. So this point is called as takeoff point. This point is called as takeoff point. Takeoff point, right? Now, if I want to move this takeoff point after a block, presently this point is ahead of the block. I want to take this point after the block. Means I want to bring this point over here. Basically, I want to move this signal over here, right? So while moving this point after the block, we have to remember one thing, that whatever the output presently I am getting, as y1 and as u1. The same thing I should get after moving this point, right? So just see. Presently, y1 is having how much gain? G1 into u1. This signal u1 is coming, multiply by g1, will get the y1. So presently, y1 is g1 into u1. And here, u1 input is coming. The same input I have taken here as u1. So presently, the value of this signal is u1, right? Now, after moving this point after the block, right, the same value of y1 and u1 means I have to get, right? That we have to take, means this we have to taken into consideration that y1 should be g1 into u1 and u1 should be u1, right? After moving this point after the block, right? Now, just see how we will move. I have just moved this point here like this. Now just see. Now presently I've moved this takeoff point here, right? Now just see what I'm getting here, the value of y1. So y1 for this block diagram, I'm getting here u1 into g1. So I will write u1 into g1. And what is u1, this signal? Now, this signal is basically u1 into g1. We are getting as y1 and the same signal I have fetched here. So presently for this figure, I'm getting the value of u1 as u1 into g1. Basically, I'm getting the value of this signal as u1 into g1. Don't write this u1, right? u1 into g1. Now just compare the values of y1 and u1, means this signal, right? Just compare the value of this signal and this signal with these two. So here, the value of y1 is g1, u1. Here also the value of u1, g1, value of y1, right? But here, this signal is having value u1. And here, this signal is having value u1 into g1. So this is not matching, right? We want u1 here. After moving this block, this point, I want here, at this signal, I want u1. Right? So what we'll do here for getting this u1, we will add one block over here, which is having a value of 1 upon g1. If I add this block over here, having a value of 1 upon g1, now just multiply. I'm getting here u1 into g1. Then this signal is going here, u1 into g1 multiply by 1 upon g1. So what will get? Multiply by 1 upon g1. So this g1 will cancel out and you will get this signal as u1, right? So in this way, we can move this takeoff point after the block. So from this rule, we have understood that whenever we are taking the takeoff point after the block, we have to add one block of the gain, which is having the value of 1 upon g1. That is 1 upon the value of the gain of this block, right? Suppose the gain of this block is g2. So you have to write down 1 upon g2, right? So this is the rule number 3. So always remember, while moving this takeoff point after the block, we have to means हमें ये चीज का ध्यान रखना चाहिए कि the value of y1 and u1 should not be changed. Basically, the value of these two signals should be the same after moving the takeoff point, right? So this is the rule number 3. Now we'll see the rule number 4. Now here the takeoff point is after the block. Presently it is after the block. Now I want to move this takeoff point before of the block. I want to take this point before of the block. Now again the same condition will be applied here, that before moving and after moving, the value of y and the value of this signal and this signal should be the same, right? Suppose this signal I am representing by A and this signal I am representing by B. So presently the value of this A signal is u into g, right? That I can say y. ये y है ना? ये y is nothing but u into g. U multiplied by g, I am getting here this signal. The same signal we are fetching here. And suppose the value, the name I have given this signal as b. So the value of this b is presently u into g. That is, I am getting here y as u into g. Right? Now, I am moving this point ahead of the block. अच्छा, एक चीज आपको अच्छे से समझनी है कि अहेड क्या होता है एंड आफ्टर क्या होता है. जस्ट सी द फ्लो ऑफ डायरेक्शन of these signals is from input side to the output side. If we are moving the point in the flow of the signal, right? If we are moving this point in the flow of the signal towards the flow of the signal, this means that we are moving the point after the block. अब suppose I want to move this point to at this location, right? तो इसका मतलब क्या हो रहा है कि डायरेक्शन ऑफ फ्लो जो है वो ऐसा है, फ्रॉम इनपुट टू आउटपुट, एंड आई एम मूविंग दिस पॉइंट जस्ट अपोजिट टू दिस डायरेक्शन. तो इसको बोलेंगे अहेड ऑफ द ब्लॉक, राइट? सपोज वी आर मूविंग द पॉइंट इन द सेम डायरेक्शन ऑफ द फ्लो, तो उसको बोलेंगे आफ्टर द ब्लॉक. इफ वी आर मूविंग दिस पॉइंट अपोजिट टू द डायरेक्शन ऑफ द फ्लो ऑफ द, इसको ऐसे बोल सकते हैं, जो सिग्नल का फ्लो है, द डायरेक्शन ऑफ सिग्नल का जो फ्लो है उसके अपोजिट में हम लेके जा रहे हैं. दिस मीन्स दैट वी आर मूविंग अ पॉइंट अहेड ऑफ द ब्लॉक. दिस थिंग ऑलवेज यू हैव टू रिमेंबर while taking the points after and before the block. So now I'm taking this point ahead of the block, right? I'm moving this block in opposite direction of the flow of the direction of the signal. So I have taken this point like this, right? Now just see what y1 I'm getting here. Here y1, the value of y1 is nothing but u1 into g1. So this will be u1 into g1, suppose. And here, actually consider this as u1, this as g1, right? Here I got u1 g1, here also u1 g1, here also u1 g1, right? Now again, after moving this block, here I am getting u1 into g1, and this signal is having the value of u1, right? Now just compare these values. So y1 value, so suppose y1, this is y1, this is y1. Now y1 value is having u1 g1 before moving the takeoff point, and here the y1 value is again having the u1 into g1 gain, right? So these two things are similar. Now just check this signal. Now this signal is having the value u1, but here this signal is having the value u1 into g1. So this is not matching, right? Now I want the same value over here after movement, right? So what I have to do? I have to multiply the gain g1. So I will add one block over here and write the gain as g1. Now just see. Now the value will become, the value of this signal will become u1 into g1, right? So from this rule, we have learned that moving a takeoff point ahead of a block means we have to add one block having the gain of g1, right? Means this gain. यानी जिस ब्लॉक के पहले आप मूव कर रहे हो पॉइंट को, टेक ऑफ पॉइंट को, उस गेन की वैल्यूज का ब्लॉक आपको यहाँ पे ऐड करना होगा, राइट? वी हैव टू ऐड वन ब्लॉक हैविंग द गेन g1. means g1 means what? Suppose in this block g2 is written, so we will write down g2. So we have to add one block having the gain of this block, right? So this is a moving a takeoff point ahead of a block. This is rule number 4. Now moving towards rule number 5. Now just see. Suppose while doing reduction, means while applying block diagram reduction technique, if you find out that summation pointing is there and one block is there. Now I want to move this summation block after the G1 block. I want to move this summation point after the G1 block. Achha, why we are doing all such things? As I told you, while doing while doing a block diagram reduction technique, always remember one thing, that a complex system is having number of blocks. We want to reduce those blocks into a single block. And then we will, by using that single block, we will find out the transfer function. It becomes very, very easy to determine the transfer function from the single block, right? So suppose while doing the reduction, if you find out that summation point is ahead of this block G1, and if you are seeing that if I'm shifting this summation point after the block, so it will become easy for me to reduce the circuit, right? So for that, I have to take this movement, right? I have to take this move. So what we'll do, just see how we'll apply this rule. I want to move this summation point after the block. So what I will do, just see, again the same condition will apply while doing movement. Before movement and after movement, the value of this signal and the value of this signal should remain same, right? So just check, what is the value of y1 here? Here at this summation point, I am getting u1. u1 is having positive polarity and u2 is having negative polarity. So basically at this summation point, two input signals are coming. u1, if I take the algebraic sum, so I got u1 minus u2. So this signal is producing u1 minus u2 value, right? Now this block is there. So now this signal will be multiplied with the gain of this block. So it will become this signal, I got u1 minus u2 multiplied by g. This is the value of this signal. That is y1, which is equal to u1 minus u2 upon g1, right? So this is the value of y1 here. Now again, I have moved this summation point after the block, right? Now just see what value I'm getting here as y1. Here, the value at this signal, I'm getting the value u1 into g1. From this point, I'm getting the value of u1, u2 signal, right? So at this point, I'm getting u1, g1 minus u2. So basically, y1, I got this value. Basically, the value of y1 I got as u1, g1 minus u2. Now just match it. Here I'm getting, if I open this bracket, so g1, u1 minus g1, u2, right? Now just compare this value with this value. So u1, g1, I got here. The same thing I got here also. Here I'm having g1, u2, but here I got only u2. This means that something I have to do here, right? Because मेरे को ये दोनों values को एक जैसा करना है. तो what I have to do? I have to add some g1 also here, right? तो कैसे होगा वो? If I add one block over here, if I add one block here of the gain g2, so what will be the value of this signal now? From here, we are getting y2 multiplied by g2. So at this signal, I'm getting the value y2 into g2. Now just see, this is the summation point. So now I will get the value of y1 as u1 g1 minus y2 into g2. So this is the value of y1. Now both these values will be equal. So right now I'm getting u1 g1 minus y2 into g2. y2 into, actually this is g1 now. So the value of this block should be g1. The value of this block should be g1. So I will write here as g1. So basically I'm getting y1 as u1 g1 minus u2 into g1. Now just see, this value and this value are same now. So this is the exact movement of the summation point after the block. So what we have done, if we are moving a summation point after the block, so in that case, we have to add one block at the signal having the gain of this block, having the gain of this block. Suppose this block is having gain G3. So you have to add the block of G3 over here, right? So moving a summation point after the block, we have to add the block having the gain of this block, right? So this is your rule number 5. Now we'll see the rule number 6. Now the rule number 6 is moving a summing point before or ahead of the block. We are saying ahead of the block, na? इसको आप बोल सकते हैं before the block also, right? So presently this summation point is after the block. Now I want to move this point before the block or ahead of the block. So what I have to do here, again I'm drawing this summation point. I have moved before the block. This block is having gain G1, right? Input is coming as U1, right? And again, this is also having an input of U2. This is having the polarity minus and this is positive. सबसे पहले आप लोग as it is इसको बना लीजिए और ये ब्लॉक को जो ये समेशन पॉइंट है इसको just move it ahead of the block, right? Now just see the equation, just see the value of this I1 signal, Y1 signal. So what is the value of Y1 signal here? From here U1 into G1 is coming and from here U2 is coming. So I'm getting here Y1 as U1 G1 because this is having positive polarity minus of U2. This value I'm getting for Y1, right? Before movement. Now after movement, I have shifted this summing point ahead of the block. Now just see the value of Y1 over here. Here U1 signal is coming, here U2 signal is coming. I have just shifted this summation point as it is, right? I have not done anything right now. Now just I will check whether I'm getting the same signal value or not. The value of Y1 I'm getting same or not. U1, U2. So U1 having positive sign, U2 having negative sign. So this will become U1 minus U2 signal, right? The value of this signal is U1 minus U2. Multiply by G1. This block is there. So Y1 I'm getting here U1 minus U2 multiply by G1, right? Or if I open the bracket, I will get G1 U1 minus G1 into U2, right? Now just compare this, the value of this signal with this signal. So U1 G1, U1 G1, both are same. But here U2 is there only, here G1 into U2 is there. So now I want this U2 because before and after move, this equation should be satisfied. ये दोनों equation satisfy करना चाहिए, right? So for that, what we have to do the change in this circuit, we have to add one block over here, which is having a value of 1 upon G1, which is having a value of 1 upon G1. This block should be having a value of 1 upon G1. So now we will get here. अब देखिए क्या होगा? This signal is having the value of U2. This signal is having a value of U2 upon G1. And from this side, U1 signal is coming. So basically, we are having this value. Basically, I'm drawing here again. Just see. This is the summation point. This is the signal is coming. If I add one block of 1 upon G2, sorry, G1, right? This signal is U2. This is U1 having positive sign, having negative sign. And here I'm getting one G1 block. And this is the output Y1. Now just see. What output I'm getting here? U1. Then here it is minus of U2 upon G1. Right? Now this signal will be multiplied by G1. So what will get here Y1 as? Here I'm getting Y1 as U1 into G1 minus U2. This is U1. into G1 minus U2. This G1 and G1 will be cancelled out here. Now just match U1 G1 minus U2, U1 G1 minus U2. Both are same. This means that we have concluded in this rule that whenever we are moving a summing point ahead of the block, in that case, we have to add one block over this signal. This U2 signal, we have to add one block having the gain reciprocal of the gain of this block. Suppose this block is having the gain G3. So you have to add here block having a gain of 1 upon G3. Suppose this block is having G1 gain. So we will add one block having a gain of 1 upon G1. Right? So students, we have learned 6 rules. इसको कैसे ध्यान में रखना है, क्योंकि ये थोड़ा सा कंफ्यूजन हो जाता है कि जब whenever we are moving a take off point after the block or ahead of the block, and we are moving summing point after the block and ahead of the block. So always remember one rule. Suppose if you remember that if we are moving a takeoff point after the block, in that case we have to add one block having a gain of reciprocal of the gain. मीन्स इसको कैसे ध्यान में रखेंगे, जिस ब्लॉक के बाद में आप टेक ऑफ पॉइंट को लेके जा रहे हैं उस ब्लॉक का जो गेन है उसका रेसिप्रोकल का ब्लॉक आपको लगाना होगा सिग्नल में. राइट, वी हैव टू ऐड वन ब्लॉक हैविंग द गेन व्हिच इज having the value of reciprocal of the gain of the block through which we are moving the takeoff point, right? So when we are moving takeoff point after the block, so 1 upon G आ रहा है. Similarly, when we are moving summation point before the block, in that case क्या हो रहा है, 1 upon G आ रहा है. तो ऐसे आप कोई भी 2 रूल याद रखिए. बाकी वाले में जैसे मूविंग अ टेक ऑफ पॉइंट अहेड ऑफ द ब्लॉक अपोजिट हो जाएगा, मूविंग अ समेशन पॉइंट आफ्टर द ब्लॉक जस्ट अपोजिट होगा किसके, मूविंग अ समेशन पॉइंट अहेड ऑफ द ब्लॉक. राइट, सो दीज आर द 4 बेसिक रूल्स ऑफ ब्लॉक डायग्राम रिडक्शन टेक्निक. नाउ वन मोर रूल इज देयर, that is 7th one, which I have this reduction of this loop. Suppose in any block diagram, if you find such kind of loop, so we have to resolve this loop into a single block. We want to resolve this loop. पहले तो इसको समझना है कि ये loop है. How we can say that it is a loop? Just see this straight line from input to output. This straight line having the arrows in unidirectional form, right? They are moving towards RS to YS, input to output. So इसको बोलते हैं unidirection. This is a forward path, right? From this point, we have taken the output signal as feedback. So the direction of this feedback signal is opposite to the direction of the forward path signals, right? इसका जो direction है, this direction is just opposite to the direction of the forward path signal. This is the forward path, and we are taking this signal from this point. Output signal we are taking, and that signal is moving towards the opposite direction of the forward path direction, right? तो इस ये क्या बना रहा है, एक loop बना रहा है. Suppose I am starting this loop from this point, and we are moving like this. तो देखिए यहीं पे आके ये वापस से complete होगा, से ऐसे direction में move करते हुए. Suppose if you find out such type of loops in your block diagram. So we want to reduce this loop now, right? I want to reduce this loop into a single block having input RS and output YS. In this way, I have to reduce this block. So what will be the reduction? So already in my previous lecture, I have told you the transfer function of the negative feedback system and the positive feedback system, right? So presently, this single loop negative feedback hai. So suppose it is negative feedback, the sign of this feedback should be negative, not positive. This sign should be positive. And suppose it is a positive feedback loop, so this sign should be negative hona chahiye, right? So I'm considering this single loop having negative feedback, right? So this sign is having, this feedback signal is having negative sign. That's why it is a negative feedback. So the transfer function of this negative feedback we can directly use, because already the derivation we have seen in my previous lecture. So it's for negative feedback, the transfer function, we can write it down as GS upon 1 plus GSHS. Right? So transfer function for negative feedback is this one. So the reduction of this loop will be equal to GS upon 1 plus GSHS. So we have eliminated this feedback loop into a single block which is having a gain of GS upon 1 plus GSHS. Suppose this block diagram is having a positive feedback. ये positive हो जाता है. Means this feedback signal is having positive sign. So we can say single loop positive feedback, right? So for that purpose, the transfer function we are getting here G1s upon 1 minus G1s into H1s, right? I have written here G1 H1. So the gain of this is G1 suppose, and this is H1, right? You just consider this as G1 and this as H1. So the transfer function of this block will become for the positive feedback G1s upon 1 minus G1s into H1s. So in this way, we can eliminate a feedback loop if it is available in our block diagram directly. Means basically, this whole loop will be represented by a single block having the gain as per the sign mentioned here. According to that, you have to write down its gain. That is G1s upon 1 plus G1 H1s for negative sign, and for positive sign G1s upon 1 minus G1s H1s, right? For negative feedback, this expression. For positive feedback, this expression. Okay, so this is the rule number 7. So all these things while doing reduction of any complex systems block diagram, suppose any complex system is there and whose block diagram is there with us, we want to reduce that block diagram by using block diagram reduction technique, and after reduction we will find out the transfer function. So basically the main purpose of this reduction is to determine the transfer function. So while doing the reduction, if you find out that somewhere I want to move the takeoff point after the block or before the block, or if I want to eliminate any feedback loop. So all these rules, by using these rules, we can reduce the block diagram, right? So this is all about the rules of the block diagram. So thank you so much.